Greetings. I welcome you all to this new lecture of this course, wherein we are now going to discuss the environmental impacts of materials recycling, and we will be seeing that how it is important to pay attention to the important factors that are present in a recycling process, so that when a process is being carried out or a product is generated from a waste stream, what really happens and what are the implications that people have observed that happen on the surrounding environments. So it is not always the case that whenever we are looking at a waste material, we can just go ahead and recycle it. Not just recycling, we have to take care about what are the economic and environmental impacts of a recycling process. So we will be focusing on various methods that have been devised by studying the environmental properties, impacts, and how to quantify them. Now, essentially, quantification of impact itself is a very difficult task, because we cannot generalize the impacts. So there have been studies to address this issue, so that we can take into account of various parameters, the effects of various parameters. For instance, let's say what happens if we are using a furnace, or what happens if we are using a reagent, chemical reagent, or what happens if we are using both. So when we are thinking of these process parameters, what are its impact on the environment? We will be focusing on these outputs, and then we will be generalizing on what are the key challenges that people face when they are thinking of environmental impacts of metallurgical and electronic waste recycling. So let us begin. Materials recycling, and by materials recycling, right now we are looking at a very generalized term. So materials recycling is becoming a common practice. But this is a common practice where? It is not a common practice in most of the economies, but it is a common practice in large scale and progressive industries. Because industries are conscious about what are the resources and liabilities. So they are conscious about the resources and liabilities. So they would definitely want to invest on materials recycling, which would in general mean that they are also investing in twofold growth: energy and materials. Because if you are recycling materials, you are in turn saving energy also. So that is the way progressive and large scale industries invest. So there is a need of utilizing the natural resources. Need of resources. And this need of resources is covered by recycling materials. Now in this course we have already covered the two major categories of materials. So we have seen metallurgical wastes and e-wastes. And we've seen the internal divisions so many times. So now the most important aspect is we need resources, and how do we recover our resources if we are not recycling it? So this is a major part of our concern, that at times we are supposed to continue the generation of newer products, and at times we are losing resources. So one has to think of recent developments, and we've already seen so many different developments in so many different aspects, seeing various industries and their industrial wastes. Now, what are the environmental impacts? This is a general outline, but what is the environmental impact? There are some important questions that we need to answer. Those questions are related to environmental impacts. These questions are like this. What if we are not able to recycle wastes? What if the wastes are not recycled? So a general answer is that the exponential growth, or it is extremely large, the growth of the wastes, of the generated waste. The growth of the generated waste from, so it will come from two ends, industries and consumer ends. Will be so large that it becomes beyond the scope of landfilling. Now you cannot even think of landfilling, and it is what it is going to do, severely affect the environment. We've already seen so many times what are the key challenges when we're thinking of environmental repercussions. So if we are looking at, let's say, aluminium industry or copper industry, or if we are looking at steel industry, and we've also seen batteries and WPCBs. So if we just dump a given waste in the environment, the chemical composition is such that it is going to pollute the environment. Now, this is not a way by which we should be handling it. So a general idea is we should be devising a recycling strategy. But then comes the next question. What if, this is the second question, when we are recycling waste, the wastes are recycled, but not efficiently. So what this question really means is, we have a strategy. So it means that we have a strategy, but it's not efficient. So if a process is not efficient, then we can easily foresee that, let's say we have a strategy, it is going to recover some waste, but secondary wastes are also generated. When we think of secondary waste generation, that has to have a separate route of recycling. So for instance, in most of the pyrometallurgical processes, let's say smelting or any other process, we know that we have a very good rate of production, and it is one of the most favored route of production and recycling as well. So we are more inclined to use it. But at the same time, we also know that slag generation is always observed, almost always it is observed. So one has to think about slag recycling because it is almost inevitable. Now it is fairly possible that recovery of valuable materials into the hot metal stage, hot metal phase, is can be optimized, which means the loss of valuable materials into the slag phase can be reduced. But such optimization requires lots of trial and error, and it has to be a very much of a conscious effort. Generally speaking, many a times it has been observed that if the processes are not properly optimized, lot many valuable materials are lost in the slag phase as well. This means that we do have a recycling strategy, we do recover some of the valuable materials, but it's not as high as it should be. So ideally speaking, it means that all of the waste materials should be recovered in the way that most of the valuable materials can be extracted as much as possible. That's an ideal condition. But in reality, what really happens is we get, let's say, a major fraction of valuable materials, and some fraction is also lost as a secondary waste. So we'll write that. Optimization of process parameters should be done to avoid major losses to the secondary waste streams. Because we know that we've just seen an example of pyrometallurgical processes. Generation of waste, secondary waste stream is almost commonly observed. It means one has to just optimize the process in such a way that we don't lose valuable materials in secondary wastes. Now we'll go ahead with the next questions. What if the recycling process is fairly efficient? What if the recycling process is fairly efficient? Now it still has some or the other environmental effect. That is what we need to address. So it basically means effects. What are the effects on environment? It means that we have, generally speaking, the intention is to have extraction, removal, recovery, removal of hazardous materials, recovery of valuable materials. So in both sense I have written removal and recovery of materials, and most of the times we have been discussing metals, and reduction of environmental burden. This is what we have been ideally targeting. aim of recycling. This generally may not be the case. So, what are the effects? Let us just write. Common effects observed for recycling processes. So, when we think about it like this, let's say we have a general recycling route, which could let's say include some pre-treatment operations. So, if we have, let's say, a general recycling route, what are the observations? So, a positive observation could be, let's say, reduction of hazardous effects of wastes, and we have good resource utilization. That is one observation. The other observation is reduction in material property. Many a times the properties, mechanical properties or thermal properties or whatever it is, the properties of materials seem to be growing lesser in magnitude, and process parameters require optimization. This is very much important for general method of recycling. So, if you are looking at thermal process, and similarly we will be looking at chemical process. So, again, thermal process and chemical process. We see that in thermal process we have mixture of wastes and waste streams. Basically, these can be processed. A common example of this could be that, for instance, if we have different wastes coming from different sources, we put them in a furnace. If we find something relatively good, and if we know that by processing them together, the composition of the products, finished products, is not going to get affected much. So, one has to diligently think whether insertion of a given waste stream is really favorable or not. If that is not favorable, then of course this should be avoided. And the other observation is we have generation of gases. We have gases and secondary wastes. This we have already just seen. Similarly, if we look at the chemical processes, we have recovery of valuable materials. And we have seen this so many times. If you are looking at, let's say, leaching process, then we have good generation of valuable products. At the same time, we have generation of hazardous chemicals. Because we are using a chemical route, it is very possible that we might get hazardous chemicals, and there is the issues related to scalability. So, when we look at scalability, whether it is laboratory process or pilot scale or industrial scale, the generation of the wastes, the hazardous chemicals, the scale itself changes by large magnitudes. So that is a good major problem that we have observed. Uh, People have generally observed when we are looking at the environmental concerns of a given waste recycling process. Now, there is something called eco indicators. We'll write. So, eco indicators are basically some sort of indicators that help in analyzing the environmental impacts. So, environmental impacts are analyzed by certain indicators. These indicators are basically numbers or values, some numbers or some values that describe or they connect to the environmental burden. And this can be related to a process or a product or a system, and this is a very good way of putting some numeric values to the processes, the recycling processes. So, how do we go ahead and understand the eco indicators? So, there are some important methodologies. The important methodologies that people have formulated for the study of environmental impacts are eco indicator, '99 method, we have equalizer 2.0, recipe method, recipe model for LCIA. We know that LCA is life cycle analysis, and we have LCIA here. So, LCIA is basically life cycle impact assessment. So, we have LCIA, and these eco indicators are available essentially for comparison. So, one of the major reasons that these indicators have been developed is to put some numeric values to the processes and the products. But this does not mean that these numbers have absolute significant value in reality. These are there for comparison, and the comparison itself is very much important. So, for instance, people can compare H2SO4, the impacts of H2SO4, or let us say generation of energy in a given unit, or generation or power utilization in a given unit, and these can be compared to certain points. These certain points are basically the burden that that the process or product is implying on the environment. So, lower the eco indicator number value, lower is the environmental impact, and the comparison is very important. So, we will write the eco indicators are available for comparison. And these are for indications only, these are indicators. So, indication only. and comparison is important. So when we now have understood that people have devised methods for echo indication by echo indicators, and we have methods for putting numbers to environmental assessment, we would now look at the key challenges that people have observed when they are looking at materials recycling and seeing the environmental impacts that it has on during the process itself. So the key challenges we are now going to address. The environmental challenges. First one, high energy consumption. We already know, so for when we look at an example of, let's say, pyrometallurgy, is giving us very high production. High production rate. So it is very much of a favored route of production or even recycling. At the same time, it uses high energy requirement for operations, which means the generation of GHGs, greenhouse gases, GHGs and generation is also very large, because these such operation units would require large amount of energy. That energy will be coming from various sources, let's say fossil fuels, conventional, or at times it could be renewable also, conventional sources of energies. So this would lead to greenhouse gases. So energy consumption is very high and it leads to GHG generation, which has negative impact on the environment. The second one would be water usage. Now, water is one of the most important valuable resource in any industry. At times when we are using water for, let's say, even quenching operations, we are taking water resources and performing our operations, and when the operation is done, we are mainly focusing on the product itself and not the water resource that we have used. Now it becomes an important responsibility that the water resource that we have used is reused, or it is processed in such a way that it becomes reusable within the industry itself. Or if it is supposed to be discharged into the next water body, then the water body has to be accommodating enough to take in the waste water. That is only possible if we are recycling and treating the water before we discharge it. Many a times the industries are not able to recycle the wastewaters that they are generating. It is so it may be due to the lack of facilities for specifically dedicated to water resources. So they may have very good recycling facilities for various other materials, but wastewater generation may be a big problem for many of the industries. So water usage is a big challenge. Resource utilization. Is very important. So in connection to water usage, we'll just write resource utilization is very important, and it is based on available technology. The third one is basically logistic problems that are associated with the wastes. What do we mean by logistic problems? Logistic problems are the transportation of wastes from one point to the other. So, logistics of wastes. It is fairly possible that waste streams may require transportation. And when we think about transportation, we'll also think about the fuel consumption. Fuel consumption in the transportation. And this also implies we are in turn thinking about greenhouse gas generation. Because many a times when we think, okay, fine, we have the waste that is generated in the industry, we are going to recycle those wastes only. That is going to require very less logistical support. However, if we are thinking of waste that is generated in a different, let's say, country itself, so one has to cross the international boundaries and transport the whole wastes to, let's say, a remote location where the recycling facility is available, and there all of the wastes are being transported to, and there the recycling is being conducted. Now, this means that we are somehow contributing to the generation of GHGs, greenhouse gases, by transporting the wastes. So, the intention is correct that, okay, fine, we are thinking of recycling a waste, but because we are investing too much on the logistics, we are in general generating more greenhouse gases. We have problem of cross contamination. So when we think of cross contamination, one can just have only one single way. One can think of incineration. The waste streams cannot be separated. That is one way people have been recycling cross-contaminated waste stream. However, it may also lead to generation of hazardous gases or other hazardous waste streams. So, this means that one should be investing heavily on isolating the waste streams as much as possible before subjecting it to recycling, because cross contamination lot is very difficult to handle, and there are only very few limited ways by which people can address such a lot. There is the problem of downcycling. So, this means the generation of waste, the wastes are used for making lower property products. That is a most viable and common route of addressing this downcycling process, because at times when we think that we are recycling a material, we actually are losing on the properties of the material. So for instance, mechanical properties or thermal properties or chemical properties. So those properties are being lost when we recycle it. It may happen with many of the materials. In such a case, we are just going to downcycle or reuse them to make lower grade products. Available recycling technology. Recycling technologies. So, when we have lack of automation, this would generally mean higher exposure of humans or environment to the waste stream itself, which means that the chances of getting a disease or affecting the environment is a lot more higher, which means one should be thinking of automizing and providing lot more machines and computerizing the process itself in such a way that the human contact of the waste or the environmental contact of the waste is reduced as much as possible. The last one is basically landfilling. This is one of the most greatest challenge that people have been facing. It leads to the exposure of heavy metals, hazardous chemicals, dioxins, and so on and so forth. And we've seen so many different wide variety of materials that are lost to the environment once we think of landfilling. And all of the more modern and recent advanced technologies that are being explored, let's say in a laboratory scale or a pilot scale, or those that are industrially accepted, those strategies avoid as much as possible the idea of landfilling. They may want to bring back neutral materials, but wastes that are valuable are definitely reused as much as possible before becoming neutral. Landfilling of hazardous chemicals is going to severely and adversely affect the environment. So in today's class, we have seen so many different aspects of environmental assessment and how people are focusing on the environmental aspects and how much it is of a challenge when we're thinking of devising a recycling strategy. We have seen some important questions that would require us to think again when we are devising a recycling strategy, and how much it should be compatible with the surrounding environment, and not just humans but flora and fauna and the resources that are available, air, water and land. All of the ecosystem that we have around should be brought into the consideration while devising a good recycling strategy. In the upcoming class, we will be focusing on the conclusion parts of this lecture series. Thank you.